quality is a serious concern in South Asia. And besides that, predicting air quality, particularly in the data-sparse region, is another challenge. So we developed this idea of predicting air quality using AI, and this paper is already published. So we presented this work in Kuwait, so that you can go ahead and read details about this paper in the IEEE website, and also maybe look at RG if you have an ID. So, talking about air quality in Delhi, for example, or Dhaka, it is beyond World Health Organization standard. And if we see the deaths relating to air quality is more than 10,000 a year, for example, or which is kind of giving several respiratory disease like asthma or even premature birth issues. So we have to think about that our area, our region is a serious concern with the exposure of bad air quality. For example, I took this photo from Dhaka Sirajganj highway and is associated with dense pollution, which is in the midday is no longer fog, so the visibility is reduced, and also the air quality is poor because of the pollution around from several sources, for example factories, or if you talk about the vehicles we use with poor fueling, diesel and all. So this combustions has resulted in poor air quality conditions in this area. And the question is not really like ourselves, that we expose ourselves to the poor air quality, but what we are giving to our next generation is also a serious concern. That is why, if we look at the recent technological advancements, even we have limited data observations from the country itself, we can still apply these machine learning techniques or AI techniques to predict better air quality in data sparse region or overall the country itself. That is why, for example, we aim to develop such a model so that we can create such a management tool or forecasting tool, so that we be aware of this air pollution and create some standard for our own level of exposure. So the datasets were obtained from the DOE, and as you see in this figure, and applied with the decision tree algorithm. The details are given here, the calculations, the training, evaluations, those all information here. You also can read in the paper. If we look at the time series, for example, from Dhaka or Chittagong, because the datasets were given very smoothly, so we see that Dhaka obviously higher pollution, but we see a variation with throughout the year, which has a seasonality and also variability in this region. And that is why we get an idea to look at the relationship of air quality to wind intensity or other meteorological variables, which has significant correlation in concentration of air quality itself. So if we look at the figure here, that air quality in the country, actually overall we expose ourselves more than 70% of our time in a year to bad air quality, and the 30% or so is actually during the monsoon, which has rainy season, so the deposition is happening or the factories are all closed. So to come up with our model predictions, we see that even if our data has limited observations in various places, but the predictions from the model is good, more than 90% accuracy, so that we can actually facilitate air quality predictions based on the given data sets and apply for entire country, set a tool for knowing the air quality standard and expose ourselves accordingly. It can also help us to look at the other aspects as well. So for example, somebody can argue with air visual, which is giving free data sets, but this app is maybe data concern or other things associated with this, but in our system we can develop such a tool as well for our local condition, for our local aspects, our local policy, our local standard, to maintain air quality based on our condition. That is why for the future generation, again, if you want to think about them, so that you don't want to carry an oxygen or a tree with you for a fresh air. That is why we all have to work together to think about air quality concern seriously in the country, not only for respiratory disease but also the health and reproductive health.